Hello everyone. Today's question of the day is a bit different. It is a mixture of index and search, as well as we'll be looking into the concept of geometric progression over here. So many of you might not be knowing what is a GP. GP stands for geometric progression. Now what is a geometric progression? If I write down a series of numbers like 2, 4, 8, 16, 32 and so on, I can see that the ratio between two continuous terms to consecutive terms, it is same. Like if you divide 4 by 2, then you get 2. If you divide 8 by 4, then you get 2. If you divide 16 by 8, you get 2. If you divide 32 by 16, you again get 2. So basically we can say that the ratio between two consecutive terms is same. So this is a GP. If I talk about 2, 4, 6, 8, 10, 12, is this a GP? No, because if you divide 4 by 2, we get 2. If you divide 6 by 4, we get 1.5. So the ratio is not same. So this is not a GP. If I talk about 1 by 2, 1 by 4, 1 by 6, 1 by 8, is this a GP? No, this is not a GP because the ratio is not common between two consecutive terms. If I talk about 1 by 2, then 1 by 4, 1 by 8, 1 by 16, 1 by 32. So is this a GP? Yes, this is a GP because the ratio between two consecutive terms, it is 1 by 2. So I hope it is clear what is a GP. Here we'll be using a concept which is called sum of infinite GP. We'll see it over here. See, we have been given under root 6, then whole under root 6, then whole under root 6, and this is going till infinity. We have infinite roots inside each other. So if I separate these under roots, what will I get? First of all, I'll get 6 to the power 1 by 2. Then we'll multiply it by 6 to the power 1 by 4. Why? Because if we have under root 6 and under root 6, then we can rewrite this as 6 to the power half for this under root 6, and then we have this under root 6, and above it we have one more under root. So under root of 6, it can be written as 6 to the power 1 by 4. These will be multiplied. So we can write it as 6 to the power 1 by 2 plus 1 by 4 because two similar bases are getting multiplied, so their powers will add up. Similarly, if we were given under root 6, then under root 6, then under root 6, then it would have been written as 6 to the power 1 by 2 into 6 to the power 1 by 4 into 6 to the power 1 by 8. In that case, we would have written it as 6 to the power 1 by 2 plus 1 by 4 plus 1 by 8. Now since we have infinite under roots, so that means this sum will continue till infinity, the sum of these powers. Now there is a formula for the sum of infinite GP. It is A upon 1 minus R, where A is the first term of the GP and R is the common ratio. So you just have to put the value of these two. If I write down this whole expression, I'll be getting something like 6 to the power 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 and so on till infinity. And this will be equal to 777 6 to the power y, which can also be written as 6 to the power 5 to the power y, because 6 to the power 5 is 777. Now in the power we have an infinite GP, so its sum will be equal to A, that means the first term of GP over here is 1 by 2. So 1 by 2 upon 1 minus R, 1 minus the common ratio over here is 1 by 2, because if you write 1 by 2 and then if you multiply it by 1 by 2, we get 1 by 4 as the next term. If you multiply 1 by 4 by 1 by 2, we get 1 by 8 as the next term. If you multiply 1 by 8 by 1 by 2, we get 1 by 16 as the next term. So the common ratio is 1 by 2. So this is what we get. This will be 6 to the power 5y, because when there's a power over the power, they get multiplied. So it will become 5y. So here I'll get 6 to the power half upon half, that means 6 to the power 1. This is equal to 6 to the power 5y. Now we need to find out the value of y. So these two are equal. 6 to the power 5y will be equal to 6 to the power 1 when y will be equal to 1 by 5. So 1 by 5 will be the correct answer to this question. I hope this is understood. You just need to know how to write down these under roots separately and then sum of an infinite GP. If there is any doubt, please comment. Thank you.